Here's a bird's eye view of a gate, and this is just like your typical fence post A and B, and you've got your gate swinging open. Imagine this gate as the side of a triangle. It does not change, and the distance from B to A, another side of a triangle. Those two do not change. Those are concrete set values, but what is going to change as this gate moves open and closes is the third side of a triangle that is formed. So notice that as the gate opens wider and wider, so as this angle A grows, side BC is growing larger and larger. Using the gate concept, we have what we call the Hinge Theorem. If the two sides of one triangle are congruent to another, so in this case we have Vx is congruent to RT, and Vw is congruent to RS, but the angles between them are different. So in this case, angle V is 88 degrees and angle R is 35 degrees. Then the triangle with the larger included angle has a longer side, XW, than does the other triangle with the smaller included angle and opposite side, ST. Make sure you do recognize, though, that you must have these congruencies. Otherwise, well, if you had a smaller triangle and a larger triangle, that wouldn't make much sense to make these relations. Let's take a look at some examples. We have triangle RST and triangle UVW. Defined in the picture is RS is congruent to UV, and RT is congruent to UW. We also have that the included angle between our congruent sides are different only slightly. Angle SRT is 54 degrees, which is greater than the angle in this triangle VUW. So since this angle measure is greater than this angle measure, we can say that side ST should be greater than VW. ST greater than VW. In the second triangle, we have that DG is congruent to GF, and the other congruent side is actually EG because of the reflexive property. Every side is congruent to itself. So since they share the same side, it's congruent. So now we have two congruent sides and an included angle, which means the larger angle, the side opposite of it, is going to be larger the other side opposite the other angle. So EF should be larger than side ED. Side EF is greater than ED. Another way to write that is, well, side ED is smaller than side EF. Either way is fine. If you understand the Hinge theorem, the converse of the Hinge theorem should be a piece of cake. Remember, with the Hinge theorem, you first needed the congruent sides and then the angles to compare the opposite third side. Well, in the converse, which is the reverse of the statement, we still have congruent sides. So in this case, side AC is congruent to side DF, and CB is congruent to FE. But now we're given that third side. And what this one says is that, well, the smaller side and the larger side, the smaller side is going to have the smaller angle related, and the larger side is going to have the larger angle. So the measure of angle C should be larger than the measure of angle F, since side AB, the side opposite angle C, is larger than side DE, the side opposite angle F. Let's put the converse of the Hinge theorem to work. We start with our congruent sides, which are indicated by the tick marks, and we have side lengths for the third side. And what the Hinge theorem says is that the longer of the two sides is going to correlate to the larger angle. So measure of angle 2, which is opposite of the longer side 31, should be greater than the measure of angle 1 opposite of the smaller side. Writing that out, we have that 31 is greater than 29, so the corresponding angles should be the same. Measure of angle 2 is greater than the measure of angle 1. This is a situation where it's very important to note the differences between angle symbols and less than or greater than signs. It's very easy to mess these ones up, so just be careful. Now let's put the Hinge theorem or its converse to use. We'll start by looking for congruent sides, because to start using the Hinge theorem, we need two congruent sides of two triangles. And at first I noticed that side length 12 is congruent to the other side length 12. Also, we have that these two triangles share this middle side, and so now we have our two congruent sides. We also need to either have angles or lengths of opposite angle measures, and in particular I'm noticing here that we have angles. We have the measure of the angle between these two congruent sides is 92 degrees, and between these two sides we don't know that angle yet, so somehow we have to find this angle. And what I notice is that we have 26 degrees and 98 degrees, the other two angle measures in the triangle. So we know that all of the angles of a triangle, the interior angles, add up to be 180 degrees. So if we subtract off 26 degrees as well as 98 degrees, we should come up with the third angle measure. This is 180 minus 124, which is equal to 56 degrees. So now this third angle here is 56 degrees. We have an included angle between congruent sides of both triangles. Now we can compare the two. 92 degrees is greater than 56 degrees. I like to set it up like this because it keeps everything in line. So if we look at the opposite side of 92 degrees, 4x plus 3 should be greater than the opposite side of 56 degrees, which is x plus 8. So now we just have to solve this inequality. Solving inequalities is very similar to a way that you would solve any other problem given. You're still going to use the order of operations and try to isolate x onto one side. So I start by subtracting x from both sides as well as subtracting 3 from both sides to cancel the 3's out as well as the x's. And we get 4x minus x is 3x is greater than x minus 3, which is 5. Notice how I'm carrying the greater sign down. Oftentimes I see that we're used to writing equal signs, so we'll just kind of randomly change that to an equal sign. Be careful. So from here I divide both sides by 3, and I get that x is greater than 5/3. Now at this point I'm going to have a bunch of you, if we were working on this in class, run up to me, Mr. Q, I thought I was doing this right, and somehow I ended up with a fraction. I'm freaking out. Something's wrong. That's okay. Answers are not always going to be perfect whole numbers. In particular, what the answer here means is that in order for this inequality to hold true, we must choose a value of x that is greater than 5/3.